Morning.
Morning.
Good morning.
Morning.
Yeah, had a hang on. Yeah, I'm decided to do this from home rather than at school because that was too much of a hassle. So wait, I gotta turn that light on. Yeah, there's some things I need to get set up here. I got a late start this morning, so again, and having to get back into the anyway. Let me get this set up. Yeah, I don't know. There we go. I got the after a little bit, I have to leave here in a second. I'll be right back. But I got the video set up. I just didn't post it last night. I'm gonna put a link in the chat here in a minute. Okay. There was something else I was gonna put down. I'm scatterbrained right now. Sorry about that. Kind of late start this morning. Well, I said that already. I'll be right back. I think I'll mute myself for now. I understand about not being able to turn cameras on, but if you can, please turn your camera on. It helps me in ways I can't explain. Sorry, I just had to open up the windows so I had more ambient light in here. Oh, I thought that was someone in chat talking. That's someone outside talking. Okay. Right now I am. Y'all have any questions for me? I got the videos ready to go. I just haven't posted them yet. Where is it? I'm hunting down my the PowerPoint so I can get it started. Yeah, I'm slowly but surely getting things ready. Normally I'd have all this set up before class, before I even open up Zoom, but trying to remember. We were on slide 20. Did I say that right? Converting degrees to radians and radians to degrees, I believe. I'll pull that up. Yeah. Next week, I promise I'll be more prepared and things will go a lot smoother the beginning of class than they have this week so far. Uh-oh. So let me pull the Zoom back up. And I'm going to switch my camera. And go back to Zoom. Whoops. That's not Zoom. There it is. I got too many things open on my laptop. Okay. I'm still having issues getting MyLab going. The main issue now is getting somebody to talk to me about who knows how to do this, to get the MyLab into Canvas. So next thing, the chat window open. So where are we? Okay. Whoops. That was a no-no. All right. Yeah. Turn your video on, pin my screen in the upper right-hand corner of my screen. That shows my lovely face. Roll your mouse over that and there'll be 3 dots to the right click that and scroll down to where it says pin, and so it'll pin my screen there. One reason to do that is to avoid distractions from the other videos that are up. And and I don't know any other reason I would have for that. Okay. All right. And let me do this. Yeah. Okay. Yeah, and then most of y'all have already done this, is to put your full name in the chat, the name that's in ACES. If if you go by a nickname, go ahead and put that after your name inside quote marks. Okay, so that way I'll know what to call you if you don't go by your full name. I go by Thomas. Not every Thomas goes by Thomas. Most of them go by Tom. So when my wife and I first met, we met in church, and I was known as Tommy at church, and I was called Tom and Tommy at home, and I didn't like to be called Tommy. I'd rather be called Tom. But my wife had an aversion to the name Tom, so she called me Thomas, and so I go by Thomas now. And that's been, damn. My wife and I have known each other for 50 years now. We first met when I was 13 and she was 11. That's when we met. And we're 3 years apart in age. No, she would have been 10. Damn. Or was I 14? No, I was 14. That's right. Okay. Yeah. And I tell people, if my daughter started seeing someone who was 3 years older than her when she was in her teens, that wouldn't have flown very well. Okay. Enough chit chat about me. Time to move on. And there we go. Okay. How much of this did we cover? Did we start doing this? Degrees to radians and radians to degrees? I don't think so. So I think I remember talking about pi over 180 and 180 over pi. These are unit fractions. They're unit fraction because these are in radians and this is in degrees, but pi radians and 180 degrees is the same. Okay, so it's just a matter of which way you do the divide. If I divide by radians, then I get 180 over pi. If I divide by degrees, I get pi over 180. So these are equal to each other. Put that one back in there because they equal 1. I know for those of you who took chemistry, you did, oh, what is it called? I forgot what it's called now. But you did changing from one unit to another unit. This is what you would do. If I want to change 12 inches to the number of feet, I would multiply by 1/12 because 1 inch is a 12th of a foot. So that would convert the inches to feet. So this is 1 foot per 12 inches. And if I wanted to convert feet to inches, I'd flip the fraction. It'd be 12/1. So that's the concept we're using here. God, I wish I could remember what that was called. Conversions, yeah. Because we're converting from one kind of unit to another. So when they talk about, so 45 degrees, when you're converting from degrees to radians, I want to put the pi into it. So that means I'm going to put pi in the numerator and 180 in the denominator. So 45 degrees times pi over 180. Well, 45 over 180, well, that's 1/4. So this ends up being pi fourths. So 45 degrees is the same as pi over 4 radians. All right. 210 degrees, if I multiply by the pi over 180, let me think. I think that's 7 pi over 6 radians. Because 3 goes into, well, you have 210 over 180. You're going to see my thought process here. That's dividing by 10 takes away the zeros. And then 3 divides both 21 and 18. So 3 into 21 is 7, and 3 into 18 is 6. This is what I would do in my head without thinking about it. And so we want to talk about a negative 60 degrees. Well, negative 60 degrees by times pi over 180. Well, I do the same thing. 6 over 18 is 1/3. But it's negative. So this is going to be a negative pi over 3 radians. All right. So 1 degree is pi over 180. Yeah. And that's basically what they're doing. They go to something you'll hear me say a lot is we're always multiplying by 1. Well, 1 can take many forms. That's what you use when you're converting fractions from one denominator to a different denominator. You're multiplying by another fraction that equals 1. And that's what we do here. Okay, because this fraction here equals 1. I'm not changing how much it is, I'm changing what it looks like. Okay, I'm changing the measure from degrees to radians, but I'm not changing how big that angle is. And they did the same thing here. And the same thing there. Keeping the sign, because that means for this angle, we came down here. We went this way instead of that way. Because it's a negative angle, we go clockwise. Positive goes counterclockwise, where this is 0 degrees. So this would be a negative pi over 3, or negative pi thirds. Pull this up a little bit more. Please let me know if you can't read what I wrote, and I will rewrite it. Okay. So with 100, we did the same thing. So 10 over 18 is 5/9. So 5/9 pi, or 5 pi over 9. And then 109, I think is 109. I think 109 is prime. I'm not 100% sure on that. Oh, they went and divided it out. They didn't say to do that, did they? Because 109 over 180 does not reduce. So what they did 109 times 3.1415 divided by 180. Or if in your calculator you have the pi symbol, you can multiply with that. And looks like my particular calculators I have in front of me do not have pi as an option. Huh. I know the graphing calculators do, like the TI graphing calculator. Okay. Questions? So to get from this to what they have here, to get from this to here, they use a calculator. Multiply the 109 times 3.1415 and divide by 180 and round to 3 decimal places. Most times that's what we do, is round to 3 decimal places. Sometimes you're asked to round to a specific number of decimal places. Sometimes you're asked to round to 2 or 3. Most common is 3 decimal places. And so that's what I always do. There's sometimes I round to 2 or even 1. Sometimes I round to the units place. So they would round this to 2 radians if they did that. Okay. Now to convert from radians to degrees, you're multiplying by the other fraction, by 180 over pi, because you want to take pi out of it. Here we go. So we have pi over 4 times 180 over pi. Because this fraction is the same as 1, it's going to take pi out of it and leave the degrees in. Because dividing by the pi takes away the radican measure, and the 180s puts in the degree measure. So this is just 180 divided by 4, which is 45 degrees. Okay. Letter B, we'll do theirs. So letter B is done the same way, where they're going to multiply by the 180 degrees over pi, because this is just 1. So they do the 7 pi 6 over 6. I sometimes say the fraction times pi. So this would be 7/6 pi times 180 divided by pi. So the pi's cross out. They don't cancel, because cancel implies 0. What they do is they go to 1, so they disappear. And then 6 into 180, 6 divides 180 quite nicely. That's going to be 30. And so 7 times 30 is 210. So it becomes 210 degrees. -3. So they're just doing the exact same problems, but they're going from the radians back to the degrees. And so we're going to multiply by 180 over pi. So this is it's somewhat easy to see. I want to put pi into the expression, or I want to take pi out of the expression. So if I want to take pi out of the expression, that means I'm going to use 180 over pi. If I want to put pi back into the expression, turn it into radians, then it's pi divided by 180. And we get the -60 here because the 2 pi's go to 1, and then 180 divided by 3 is 60, and it's negative. All right, this is a different one than what they had given us before. But still, we're going to multiply by 180 over pi. The pi's get canceled out. Not canceled out. The pi's go to 1, and then I can divide the 180 by 2. So I have 5/2 pi times 180 over pi. The pi's went to 1, and the 2 goes to 1, and the 180 goes to 9. So that's 90. And 5 times 90 is 450 degrees. So 5 pi over 2 is more than one revolution. Yeah. I've been saying rotation, but it's technically a revolution. And you subtract 360 from that, and that'll tell you what the reference angle is, or which is what? 90? That's a 90-degree angle. Okay. And then this one's a little different because there's not pi in it, but it's in radians. So something got multiplied by pi to get 2.5. So I want to multiply, because I want it to become degrees. I'm going to multiply by 180 over pi. So in the calculator, I would multiply these two first. I would be 2.5 times the 180. And once I did that, then I would divide out the 3.1415, and I get an approximate answer. And they're saying it's 143.24 degrees. Any questions here on this? From my mind, this is easy, but from your mind, it might be confusing. So let me know. All right. Okay. Okay, so this is an example. Field of view for small angles, the length of an arc. Yeah. And that's what we talked about when we talked about the length of an arc is S, and that length is the radius times theta, and theta is in radians. Okay, so it's using pi. So here they're saying that theta in degrees is 6 degrees and 9 minutes. So to convert this to radians, the first thing I need to do is make this be totally in degrees. So that means the 9 minutes needs to be converted to degrees. So I would divide by 60. And that becomes 3 over 20. Do that right? So that's going to be 1.5 and divide, so that's 0.15. Did someone put this in a calculator and get 0.15? Okay. I always double check my mental math because I'm known for making mistakes. So 6.15 degrees, I multiply that by pi over 180. And that'll give me the number of degrees. So if I write this, I mean the number of degree, the number of radians. So 6.15, oh, I forgot the zero, divided by 180 pi radians. If I multiply that by the 725 feet, because that's the distance from the camera to the image or to the object they're taking the picture of. And I multiply that by 6.15 pi divided by 180. So I'm setting all this up to tap it into the calculator. So I do 725 times 6.15 times 3.1415, and then I divide whatever I get there by 180. Okay, and this is just what they're talking about here. So the field of view, they talk about the field of view. And so we have this arc length. Oh, and this distance here is different than that distance there. And I don't think they gave us the formula for that. Convert the angle to radians. Yeah. And so this right here is 0.107. I trust their calculators, although you shouldn't. And then they multiplied by the 725 and get 75 point whatever, 75.575 feet, which I would probably round to 75.6, just because this is hard to measure. So, all right, before we move on, any questions on this? Okay. So, oh, get my laser pointer up. Okay. So now the area of a sector. You all know what a sector is? Let me back up here. This triangular area here, including the arc up here, not this line segment. This is a sector of a circle. So a sector of a circle has area. It's a portion of the circle, just like a arc is a portion of the circumference of the circle. And this is, and so that formula, how we derive that formula is the area of a circle is pi r squared. Well, pi is the radians, right? And so so that's this here, the radians. But we need to talk about what portion of the circle it is. Oh, where did they get the 1/2 from? So theta is oh, I have to think about this. I'm not gonna try and derive that formula. I like to derive formulas, but the area of a sector is the 1/2 times r squared theta. Yeah, think about the area of a right triangle is 1/2 base times height. And that's kind of where the 1/2 comes from. All right, but it's not an exact equivalent. So if you know the angle and you know the radius, you can find the sector length by r theta, and you can find the area by 1/2 r squared theta. So in this problem, theta is 45 degrees, which if I multiply 45 degrees by pi over 180, that will turn it into the radians. And this happens to be pi over 4 radians. I know my radius is 3 meters. So I just plug it into the formula. It's 1/2 times 3 meters squared, so I'll get square meters at the end, times theta, which is pi over 4. So I square the meters. So this gives me 1/2 times 9 meters squared, and the meter squared is going to wind up at the end of the number, times pi over 4. So I do the appropriate multiplies and I get 9 pi over 8 meters squared. Now, if I was to give you a problem like this on an exam, this is the answer I'm looking for, because I'm going to look at the procedure on how you got that. I don't need to know how proficient you are with the calculator. Okay. And besides, this is an exact answer.
Excuse me, where did you get the 8 from?
The 8. Oh, because I'm multiplying 1/4 times pi over 4 times the 9. I mean, 1/2. I wrote 1/4, didn't I? 1/2 times pi over 4. I multiply the denominators together, and then I multiply all the numerators together.
Oh, okay.
That help?
Yes, thank you.
Okay. I firmly believe that if you understand how to manipulate fractions, adding, subtracting, multiplying, dividing, just changing how you can change fractions, all of mathematics is easier, because being able to look at fractions and be able to see them in different ways helps you see math problems in different ways. I firmly believe it's an extremely helpful tool to help you understand mathematics. I know a lot of people are afraid of fractions. I used to be. So they use that, and let's see what they do. Yeah, they're doing only they didn't have the 3 meters in there. I kept the 3 meters in there. I kept the meter in there because we're going to end up talking about square units, and so it's meters squared. And they get that. Do they multiply it out? Yeah, they multiplied it out. And so they're saying the area is 3.53 square meters. And they wrote out square meters rather than using this notation, which is fine. I don't care how you do it. If you want to write it out in words or use the notation. The reason we have notation is because mathematicians are inherently lazy and they don't like to write it all out like square meters. So they came up with a notation like this. So square feet, put the little square on the abbreviated feet. Okay. Now, linear speed. A lot of the stuff in this section is extremely useful. It's good to have in your head, especially when you move on beyond calculus, if you're going that far. And it's even good to help your brain. The more you know, the more you can well, the more you learn. I heard a paper. I went to a conference and heard a paper on brain stuff, and this was when it was first cutting edge stuff. And what they determined was that the more you learn and the more you problem solve, the more your brain builds more dendrites between the brain cells. And the more dendrites you have between the brain cells, the more you have access to other information in your brain that you don't have to work hard at getting. And it actually makes you more intelligent. So you can affect your IQ score. It's not set in stone like I was taught. Okay, linear speed. V is always velocity in mathematics and in physics. So in velocity, what is velocity? When I talk about the velocity of my car, what am I talking about? Anybody know? Somebody should know.
Is it how fast it goes? Like,
Exactly. It's speed. Velocity is speed. Notice it says linear speed v. Well, that's the velocity. Okay. But sometimes they talk about velocity and speed as them being different things. Well, sometimes they are. Speed is how fast you're going from a certain point. Velocity is speed and direction. Because you can have negative speed. That means you're going in so here's your point of reference. Negative speed, negative velocity means you're going this direction, where positive means you're going in that direction. So again, negative means direction. It doesn't affect the numbers themselves. I've had to learn that the hard way. Nobody took the time to explain it to me, which was to my detriment. Okay. So the velocity of an object is the time, the distance traveled divided by time. And here, this S here is the arc length. All right. Here we go. Come on. Change. Yeah, velocity is distance over time. Or it's like miles per hour times the number of hours equals how far you've traveled. And then you just divide by the time. So your speed, the speed of the car, is the amount of distance you traveled divided by the time in hours. That's all this formula is. There's nothing special about it. So, and they use S over T because the S is the arc length, which is the distance. So angular speed, and this symbol here is the Greek letter omega. This is the lowercase. The uppercase looks something like this. In electronics, that's the ohm symbol for ohms, the amount of ohms, which I have no idea. I have no idea about electricity. That's physics, and I'm not good at physics. All right, and the angular speed of an object is the angle, is the measure, is the angle measured in radians swept out divided by the elapsed time. So that's the angular speed. That's how fast is the angle growing. So omega is a measure in radians per unit of time. So how many radians per second? How many radians per hour? Okay. That's what this measure is. All right. So we've got these two formulas we're going to be dealing with. Let me switch. Let me get a new page up. So we have the velocity is the arc length divided by time, and the angular speed is the degree in radians divided by the time. So the formulas are very similar. It's just one's using the arc length and the other is using the angle measure. All right, a child is spinning a rock at the end of a 2-foot rope at the rate of 180 revolutions per minute. Find the linear speed of the rock. All right. So the rock is moving around a circle at a radius of 2 feet. So R, because R is 2. So S S is R theta. So S would be 2 times 2 times 2 pi, because they're talking about 1 revolution. So S is 4 pi. And it does 180 of these revolutions per minute. Wow. So, well, let me see how they're doing it. Yeah. So it's the number of revolutions per minute. 180 revolutions per minute. So yeah, they multiply that by 180 times, well, the angle is 2 pi, so that's going to be 2 pi divided by well, for each 1 revolution per revolution per minute. And so that's 1 minute here, and they do 180 of these per minute. And so that's where they're coming up with this. So it's 360 pi radians per minute. And then the linear speed, that's what I was doing here. And that'd be 4 pi per minute. No. See, this is, well, where velocity is pi omega, or radius omega. That's a formula they did not give us. So they threw that at us. It's because if omega is theta over t, yeah, because all right, since S equals r theta, then I can rewrite this as r theta over t. I can write this like this, and this is just r times omega, theta over t, which is r omega. So they did not give us this, but we could derive it. And what else? So we know what omega is. Omega was that was the 360 pi per minute. Can't spell right now. Pi radians per minute. So radians per minute. So multiplying by 2, that's going to be 360 times 2, which is 720 pi radians per minute. Oh, no, it's feet, Thomas. Pi feet per minute. Yeah, this will be in homeworks. I really have an issue with putting this on exams. I may ask for the formulas, but yeah, you could see how I got confused. So I'm not going to do that to y'all. But you will see it in the homeworks. And they went ahead and multiplied out by pi 3.145 and then rounded to the nearest unit. Okay. And then they went through the trouble of converting that to miles per hour. One mile is oh yeah. So 1 mile per hour. 1 mile is 280 feet per minute. And so that would be no, I'm writing it the wrong way. So to convert feet to miles, you would divide by 5,280. Did I remember that number right? And then you would multiply by 60 minutes because it's 60 minutes per 1 hour. And so I want to take the hour out and put the minutes in. And so that's how you would divide it. Multiply it. Is that right? I don't know. I think I got this wrong. But anyway, yeah. Oh, I wouldn't. And by the way, if I gave you this type of problem, this would be the answer I'm looking for. I wouldn't need you to convert it to miles per hour. Or actually, this is all I would need because I don't beyond just calculating to pi how many pies. I don't, because this is an exact answer where this is an approximate answer, and I like to have the exact answers. If they ask for an approximate answer, they will ask for a certain number of decimal places. Okay, they'll say round to the thousandths, or round to the second decimal place, or round to the units, whole units. So, all right. The unit circle. The unit circle is a powerful tool. Through the unit circle, we can find exact values of trigonometric functions using a point on the unit circle. We can find exact values of trigonometric functions of a quadrantial angle. If you remember, a quadrantial angle is one of these 4 angles that are on the X and Y axis. We have 0 degrees, we have 90 degrees, we have 180 degrees, and we have 270 degrees, and 0 is also the same as 360 degrees. That's just a full revolution. Find the exact values of the 45-degree angles. 45-degree angles, we have actually all the angles I've drawn here are 45-degree angles, because 0 plus 45, and then 45 plus 45, and then 90 plus 45, and then and this is 135, and then 135 plus 45, and 180 plus 45, and then 225 plus 45, and then 270 plus 45, that's 315. And then I add 45 to this, that gives me the 360. So each of the oh, this I didn't write down the 45. So each of these is a 45-degree angle, or a multiple of 45. So I talk about the 45-degree angles. I also talk about the 30-degree angles. The 30-degree angles and the 60-degree angles, all 60-degree angles are a 30-degree angle because it's just a multiple of 30. So there's some similarities in their trig functions values. If you remember from high school geometry, we have two triangles that we played with. And we had the 30, 60, 90-degree triangle and the 45, 90-degree angle. And this is 1 square root of 2. And this is 1, 2 square root of 3. And you could figure out your trig functions. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and those things from these two triangles to figure out what the trig functions are of those certain angles. Well, I'm going to show you a trick here that a fellow professor of mine showed me that showed me several years ago, and I just recently started using it. But we'll get to that in a second. So, come on. And then we're also going to find exact values of multiples of 30, 45, and 60. I kind of hinted to that already. Use calculator approximation. That means you just use the sine, cosine, tangent, or of whatever's. This doesn't have. Oh, okay. And then there's a thing known as arc sine, arc cosine, and arc tangent. We'll get to that in a little while. We used to use this word, arc sine and arc tangent and arc cosine, but they've started doing it this way. Inverse, sine to the -1 is the inverse of the sine function, which is what happens here. But we'll get to that more in depth to that later. I'm distracting myself. Okay, and then use circle of radius r to evaluate trigonometric functions. So the typical trig functions you're dealing with, the radius of the circle is 1, and that's what we're dealing with here is the unit circle. The unit circle is a circle whose radius is 1 and whose center is at the origin of the triangle. I mean, of the coordinate plane. And there we go. And this is what a unit circle typically looks like when done. This is the x-axis. Whoops. This is the x-axis going across here. And this is the y-axis coming down here. I don't trace very well. Okay. The unit circle, any circle of radius r has a circumference of 2 pi r. And since this circle has a radius of 1, then this circle, the circumference here is 2 pi. So 1 revolution is 2 pi. And the revolution is, all right, remember arc length? Arc length is r times theta. Well, in this case, r is 1. So the arc length is whatever theta is. So if I talk about a complete revolution, then I'm talking about 2 pi, which is the same as 360 degrees, which is 0 degrees or 0 pi. So if I go half the distance, that's half of 360, which is 180. So this is also half of 2 pi, which is pi. Yeah, make this a little better, easier to see. Let me see. Okay. And so this quadrantial angle is half of half of a half. So it's half of 180. So this is my 90-degree angle, or half of pi, which is pi halves, or pi over 2. And so between 0 and 90, halfway is 45 degrees, and half of 2 pi is, pi halves is pi fourths, because half of a half is 1/4, because 1/2 times 1/2 is 1 over 2 times 2, which is 1/4. Questions here? And so I could, and then also in here, a third. So these two are a third of the 90. So here I have 1/3 of 90, which is 30 degrees. And if I add 30 to 30, that gives me 60 degrees. And 30 to 60 gives me the 90. So these are the third angles. So a third of 2 pi is 1/3 times, pi over 2. 1/3 times pi halves is pi over 6. So if I add pi over 6 to pi over 6, that gives me 2 pi over 6, which reduces to pi thirds. So that's a third of this half circle, right? A third of pi is 1/3 pi, or pi thirds. And then I can build the other angles off of that. But I think they go in a different direction to start with. They start talking about the trig functions. Let t be a real number, and let p is a point with the coordinates x, y. All right. The sine function associates the t with the y coordinate of the point P. And the cosine function associates t with the x value of the coordinate of P. So whatever. So we're saying sine of t equals y, and cosine of t equals x. So I can rewrite the point xy as cosine t sine t. Yeah, I wish they didn't dive into this right away, but and tangent is cosine over sine. No, sine over cosine. Well, sine is y, cosine is t, so the tangent of t equals y over x. And they get into the cosecant, the cosine, the cosecant, and the secant, and the cotangent. Cosecant is 1 over sine. So that's why cosecant is 1 over y, because y is sine. And the secant is 1 over cosine. And so the secant is 1 over cosine, and cosine is the x value. And then cotangent and tangent are just inverses of each other. And so that's why cotangent is x over y, where tangent is y over x. Okay. Now, finding the values of the 6 trigonomic functions using a point on the unit circle. Oh, by the way, this is a PDF file I have, and it has 2 pages to it. Oops. Here we go. Let's see, here we go. And so we talk about degrees, radians, and coordinates. All right. With a unit circle, we're not concerned about the radius because the radius is 1. And that's something we will concern ourselves with it after a while. So the point -1/2 square root of 3/2. So that's this point here. Yeah, this PDF file, I meant to already have it in files, and so after class today, I'm going to post this into files so you have access to it. You can print up a copy of it. And I suggest you do that, print up several copies, and just practice filling this thing out. And I'll show you how to do that after a little bit here. Okay, on the unit circle, yeah. And so the sine of this angle, which happens to be 2/3 pi, sine of t is going to be the y value, which is the square root of 3 over 2, because this is -1/2. The x value is negative because we went to the left of the y-axis, and the y value is positive because we went above the x-axis. And that means cosine of t is going to be a -1/2. And so that means the tangent of t is going to be the square root of 3 over 2 divided by a -1/2 over 2. The 1/2s go to 1. And so that leaves us a negative square root of 3 over 1, or a negative square root of 3. And then the cosecant is just 2 over the square root of 3. The cosine is going to be a negative, the secant is going to be a -2, and cotangent is going to be 1 over negative square root of 3. All right, so yeah, so the x, oh, I didn't write the square root of 3 over 2 up here. The x is -1/2, and the y is 3/2. I mean, square root of 3/2. And whoops, I hit the wrong button. So, oh, they did sine, cosecant. What else? Tangent. And they worked it out similar to how I did it to find that cotangent. And then they did cosecant. And then they found secant. And then they found cotangent. So when I do cotangent is just 1 over tangent. So that's 1 over negative square root of 3. And when you rationalize the denominator, it's going to be a negative. That means I'm going to multiply top and bottom by the square root of 3. So I get square root of 3 over 3. Secant is 1 over cosine. So that's going to be 1 divided by a -1/2, which is just the reciprocal of -1/2, which is a -2. And sine, cosecant, always write it wrong. Cosecant t is 1 over sine t, which is 1 over square root of 3 over 2, which is the reciprocal of square root of 3 over 2, which is 2 over the square root of 3. And then when I multiply the numerator and denominator by the square root of 3, I get 2 square roots of 3 over 3. The square root of 3 times the square root of 3 is 3. And 2 times the square root of 3 is 2 square roots of 3. Now, this is called rationalizing the denominator. In mathematics, we don't like square roots or any kind of a root in the denominator, so we multiply by something to make the square root go away from the denominator, and that very often puts it in the numerator. Okay. Kaboom. So when we're talking about the unit circle, we don't use t, we use theta. That's all this page is saying. Trigonomic functions of angle theta, if t equals t radians, then the 6 trig functions of angle theta are defined that way. So it's the same deal. Okay. This is when the radius is 1. Cannot stress that enough, because if the radius is longer than 1, then these numbers will change. Because now we're not dealing with 2 pi, we're dealing with 2 pi r. All right, and now they're talking about what I did here earlier, which was defining the quadrantial angles. Theta is 0 radians. If theta is 0 radians, then that's 0 degrees. If theta is pi over 2, that's the same as 90 degrees. If theta is pi, then that's 180 degrees. If theta is 3/2 pi, and I'm going to erase some of this down here. 3/2 pi, which is down here, and which is 270 degrees. Not 180 plus 90 is 270. And then if we go again, the 360, which is 2 pi, we get the same measure as if we did 0. That our trig functions would the trig functions of 0, 2 pi, and 360 are all the same number. And make sure if you're doing these calculations in the calculator, make sure your calculator is set for the appropriate unit. If you're using radians, make sure your calculator is in radians. If you're in using degrees, make sure your calculator is set for degrees. Every calculator is different as far as that is concerned. So, okay. Next thing. So a point on the unit circle that corresponds to theta. All right, let me clear all this off. Okay. I don't need that line there anymore. So this point over here, it is 1 unit in x. So x is 1 and the y value is 0. This point up here is the x value is 0 and the y value is 1, right? Because it's 1 unit in the y direction, but 0 units in the x direction. And same thing happens over here, but we're going in the negative direction. So it's -1, 0. And this one down here is going to be 0, -1. There is symmetry involved here. Please notice it because it comes in very handy. It's very useful and we use it. I'll be talking more about that in a minute. Now, so now we talk about the sign of 0. The sign of 0 is y. So here's 0 degrees. The y value at 0 degrees or 0 radians, the y value is 0. So the sign of 0 is 0. Where the cosine of 0 is 1. Okay. And tangent is y over x. So that's going to be 0 over 1, and 0 divided by 1 is 0. 0 divided by anything except by 0 is 0. 0 is one of those different numbers. Oh, I should get out my, I don't know where it is. Okay. Questions? And the secant All right, now when we talk about the inverses, the secant is 1 over cosine, and cosine is 1 over x, so that's going to be 1 over x. The secant of 0 is 1 over x, and since x is 1, it's going to equal 1. But something happens when you divide by 0. Okay, they didn't go ahead and do that, so I'm going to write it down here. Cosecant of 0 is 1 over y, and y is 0, which is undefined. Right? Dividing by 0 is different than multiplying by 0. Dividing by 0 is undefined or not defined. So that means the cosecant, which is 1 over y, and the cotangent, which is x over y, which is 1 over 0, is undefined as well. So the trig functions, you have functions that are undefined. They do not exist, not in the real numbers. Okay. I remember hearing a lot of years ago that there was some guy did a proof. It's an 800-page proof where he showed what 1 over 0 equals. But it's like he had to do transformations into 23 dimensions or something like that, 28 dimensions. I can't remember what it was, but it just seemed kind of ludicrous to do it because we don't do things in that number of dimensions. But anyway, he just did it because he could, not because there was any use for it. Which is where a lot of discoveries happen. Just doing it because you can, to find out what happens. It's where a lot of scientific advances happen. They do it just to see what happens. And so, well, you can find those, you can find the for the other quadrantial points, it's the same thing. It's sine of 90 degrees. 90 degrees is the same as pi over 2 radians. So the sine of 90 is 1, where the cosine is 0. And over here at 180 degrees, what is going on there? (180°), which is the same as pi radians. The cosine is -1, where the sine is 0. The sine of 180 and the sine of 0 are both 0. But the cosine of 180 and the cosine of 0, cosine of 0 is 1, but the cosine of 180 is a -1. And then down here at 270 degrees, which is 3 halves pi, or 3 pi over 2, the cosine is 0 and the sine is -1. And then the others can be built off of those. And that's what they have done here. They went ahead and did all 6 of them. All right, since the cosine is 0, that means the cosecant, that means the secant is not defined, and tangent isn't defined, is undefined. But in this case, cotangent here and here are both defined, and it's going to be 0. All right. So, and they do the same thing with all of these. So, hope y'all figured out the pattern here, because it's just all the same thing. This is the sine, and this is the cosine. 0 over -1 is the tangent. 1 over -1 is the cosecant. 1 over 0 is the sine. So it's, I mean, the cosecant. So it's undefined. Cotangent is -1 over 0. So that's undefined. And that's what they have up here. Right? Do they do the 270 as well? Yeah, which I kind of already did. Please notice the numbers you get here are related to the numbers you get up here. Just some of them have the same sign, some of them have different signs. And same thing with these here and these over here. The numbers will only vary by the sign. Some of them are negative, some of them are positive, but absolute value wise, they're the same number. Okay. It has to do with point symmetry, and also symmetry with respect to the X and Y axes. And so here they have the table of the quadrantial angles. Right. Once you understand how these things work, and you've got that, and you got the sine and the cosine and the tangent down, that this is the Y value, this is the X value, this is Y over X, and then the secant, cosecant, and cotangent is just 1 over their accompanying ones. So sine is with cosecant, so that's 1 over Y, and secant is with cosine, so that's 1 over X, and cotangent goes hand in hand with tangent, and it's X over Y. So there we have that. Yeah, someone has a question about MyLab. MyLab is still in process. I sent out an email to the Pearson representative, and they have yet to get back to me. I talked to my department head, and she said contact the Pearson representative. So I'm just having issues with their directions. If I follow their directions, and I'm not seeing how it puts MyMathLab into the Canvas under modules. So I'm still working on that. Hopefully I'll get it done today. Hopefully they'll send back an email and I get it today. It might be tomorrow, but I want to get it done as soon as I can, because I know it's important for y'all to start practicing this stuff. And one of the things I'm going to do is I'm going to provide y'all with this what do you call it? Let's see here, this is what it looks like, and it'll be blank, and this will all be gone from it. So so it'll be and then and here you could fill this in. 0 degrees is 0 radians, and pi over 6 is no, wrong one. 30 degrees and 45 degrees, 60 degrees, 90, and then 120, and then 135, and then 120. So that's 150 degrees, and then 180 degrees, and 210 degrees, and 225 degrees, and 240, and then 270, and then 300. Is it 300? Yeah. And then 315, and then 330, and then 360. So those are the degrees. And so this is pi over 6, and this is pi over 4, and this is pi over 3, and this is pi over 2. And from here, it's multiples of these things. Okay, so if you go down and look at the 45-degree angle ones, where's that here? It's just multiples. It's the odd multiples of pi over 4. So 1 times pi over 4 is pi over 4. 3 times pi over 4 is 3 pi over 4. And then 4 times pi over 4 is this one. And then 5 times pi over 4 is 5 pi over 4. And this one is 7 pi over 4. And then you end up with yeah, it's kind of hard. This is 30 degrees more than 90, so it's pi over 6 plus pi over 2, which ends up being let me see, that'll be 3 pi over this. Okay, so this is going to be 2 pi over 3, and this one is going to be, what is that, 5 pi over 6, and this one is just pi, because that's one of, and this one was 3 pi over 2, and this one is oh, what is that? That's going to be 7 pi over 6. This is 9 pi over 6, which is no, not 9. What is it? Yeah, 5 pi. It's 5 pi over 6. 5 pi over 3. I'm sorry. And this one is 11 pi. No, that's not 11 pi. What is it? This one is 11 pi over 6. So this one is 7 pi over 3. And this one is 2 pi. And then there's going to be a little method here about how to fill these in, the coordinates. We're at time, and so next time I'll finish filling this out. But by next time, this will be in files. I'll start putting things in files for y'all that are helpful tools to use and help with note taking as well. Let's stop the share now. Y'all have any questions for me now? Oh yeah, no, you weren't doing anything wrong. That was about MyLab. I keep wanting to say my math lab, but it's MyLab. Okay. Once MyLab gets up and running, things will go smoother here, and we'll continue on. Y'all have any questions for me? Otherwise, y'all are free to go. We're a minute past time, so better than the 15 minutes I did the other day. Y'all take care.
Thank you.
I have a
Have a
good
good
day.
day. You too. Bye-bye. Okay. Oops, Kaylee's gone. Wanted to ask Kaylee if I've had her in a past class because that name looks familiar. Lugo is not a very usual name.
Sir,
Yes.
all the assignments are going to be in my math lab.
Yeah. And that's why I'm in a panic trying to get that for y'all. I'm really working at it. I've been trying several times to install it, and they have 3 different ways of getting it in there, and I've tried all 3 different ways, but I don't see how I'm supposed to get it to work right, because it's not showing up the way it's supposed to.
Because my last math professor just told us to do it on the math lab, and he would change the grades to the Canvas.
Oh yeah, that's how it works. Yeah, you do everything in math lab, and I put in the grades directly into Canvas.
It's all done manually. You put in the grades into
Yeah,
Canvas.
yeah. And because I use the grades to help boost exam grades, you won't see those grades directly reflected in Canvas.
Okay.
They will be used on your exam grades. Because you'll see, all the grades I put in Canvas are your exam grades, plus that 10%.
Okay. Sounds good. Makes
Okay.
sense. Thank you. Have a wonderful day.
You too. Take care. Sarah, you still with us? Hello. Okay. I'm going to end the meeting, and I'll see you next Monday.